an anthropomorphized day in the life of Buttercup the bee, starring Buttercup the bee. Buttercup is one of 60,000 female workers in her hive. Today she starts her first flight out of the hive as a forager. What she doesn't know is that the year is 1967, and the scientist Carl von Frisch is observing and analyzing her activities. Buttercup flies out, fills up on nectar, and returns back home. Frisch determines that she uses the sun, polarized light, and landmarks to navigate. When she gets back home, she performs a sophisticated waggle dance to show her sisters where her food source is. Her sisters learn the relationship between Buttercup's speed and angle of the dance and the distance and location of the flowers. Wow, that dance sure seems cognitive, Mickey, is it? I don't think so, Buttercup. Sorry. It's probably just a combination of different modules and highly developed senses that enable bees to have such complex behaviors that seem cognitive. For example, knowledge of the relationship between this dance length and distance in combination with knowledge of the sun time and day enable bees to waggle dance. This does not signify cognition, but perhaps shows a higher level of sophisticated behavior. Bees have had a long time to evolve these abilities, but they seem to be rolled out stimulus responses without any flexibility in behavior. Anyway, back to the story. Buttercup decides to go out to get more nectar. However, as soon as she emerges, she is caught by another scientist and brought into the lab for many learning-based tests. The first one was categorization. In 1990, Hatteran et al. Taught Buttercup to discriminate between vertical and horizontal patterns. It could seem like Buttercup formed categories in her mind that enabled her to distinguish new patterns, but it is probably just due to orientation detectors in the bee brain, so this behavior is not cognitive either. In 2009, Gross et al. Taught Buttercup to match visual patterns with a different number of elements in a Y maze. Buttercup could differentiate between patterns with 2 or 3 elements after training, and could differentiate 3 from 4 without any additional training. This doesn't mean that bees can count, but suggests that they can form number-based generalizations, which may have been important for identifying flowers by the number of their petals. Srivanasen et al. In 1998 taught Buttercup to associate certain smells with rewarded colors in a Y-shaped maze. For example, they matched the smell of mango with the color blue and the color blue with a reward. This is accessing a module from different senses. Wait a minute, are you sure bees don't have cognition? Accessing a module from different senses could signify cognition, right, Mickey? Good question, Buttercup, but I don't think that's the case here. Mushroom bodies in the bee brain indicate higher order integration. They take in olfactory, visual, and mechanosensory information and have a multimodal output neurons. They could potentially integrate different sensory inputs in different modules and explain the multisensory learning here. So it looks like it's not cognition that makes bees so successful in these tests. Sorry, Buttercup. Here's some honey for your troubles. But bees still exhibit extremely complex behaviors that blur the line between sophisticated behavior and cognition for many species, including humans.